Welcome. We're going to work with nth roots, or different index roots, and rational, meaning fraction, exponents. So today it's a very, we've already worked with square roots. So if I were working with a square root, we would break this apart like, let's see, 2 times 64, this is 8 times 8, and then I'd break these into 3 2s. So 7 2s. And the process that we used with square roots was every time we had a pair, we pulled one out. A pair, you pull one out. A pair, you pull one out. And if it's left over, it stays inside. So you'd have a final answer here of 2 times 2 is 4 times 2 is 8, square root of 2. Now, the little thing you should know is there's understood, like when you write x, if you write x, that's understood to have a coefficient of 1 and an exponent of 1, even if it's not written. Well, when you're working with a radical symbol, that's what this symbol is, it's called the radical symbol. When you're working with that, it's understood to have an index of 2. That tells you how many you need to pull one out that are multiplied together. So if I were to take a 3 for an index, that's a cube or a third root. And we already know this is 7 2s, so I need 3 to be linked together to pull one out. So 1 2 3 2s, I can pull one out. 1 2 3, I can pull one out. And there's one left over. It stays inside the cube root, don't forget your index, of 2. So your final answer here would be 4 cube root of 2. It's easy to forget the index, so please be careful of it and watch for that. Once again, I have 7 2s. And this time I need 4 to pull one out because it's a 4th root. That leaves these 3 left inside. So 2 4th root of 8. And that's how you do that. Last one, again, there are 7 2s. And you need to have 5 in this case for a 5th root. So I connect up 5 of them to pull one out, and these are left over. So 2 5th roots of 4. Now people will frequently say 2 square root 5th of 4, and they really mess it up. It's 2 5th roots of 4. That's how it's said. So take your time to learn how to say it. Hopefully it won't be embarrassing if you make that mistake. All right. Now, in the same way we work with variables to a power in a square root, we do that by dividing the exponent inside by the index. And we didn't have to talk about an index with square roots because we just assumed it was a 2. We divide it, and that gives us the exponent outside. And if there's any remainder when we do that division, that's the exponent inside. But there is no remainder when I divide 12 by 2. So the same process is done here. 3 goes into 12 4 times, so that's your exponent outside, and it goes in evenly. Same kind of thing here. 4 goes into 12 evenly 3 times. And in the last one, 5 goes into 12 twice, but it has a remainder of 2. And there you have it. X squared, 5th root of x to the 2nd. All right, let's take a look at our next examples. This combines both together. This happens to be a cube root, so I need 3 to pull one out. I can break 120 apart into 12 times 10, 4 times 3, 5 times 2, 2 times 2 times 3 times 5 times 2. As we said before, you need 3 to pull one out. 1, 2, oh, one way over here, 3. Those are connected together. A 2 comes out. The 3 and the 5 are left over inside. So let's put that over here. I'm going to leave some room for the variables, and then I'll write my cube root with a 3 times 5. Now let's deal with the variables. X to the 5th. How many times will 3 go into 5 evenly? Once. And what's the remainder when I divide 5 by 3? X to the 2nd. 3 goes into 10 3 times with a remainder of 1. So if I multiply anything that is not currently multiplied together on the outside, it's 2xy to the 3rd. Cube root 15x squared y. 2xy to the 3rd, cube root 15x squared y. Or you can say 2xy to the 3rd times cube root 15x squared y. All right, let's take a look at variables, negative numbers in radicals. We know that in the real number system that this is undefined. Oops. In real numbers, and it is I in complex. In the complex number system, it's I. They don't, as far as I'm aware, they don't have a system for 4th root or 6th root negative numbers. So, 4th root, by the way, not possible, or undefined, however you want to word it. Same with 6th root. However, when you start getting into cube root or 5th root, any odd root of a negative number is going to be -1. Of -1, I should say, not of any negative number. It's going to be negative on the outside, and then you simplify the radical. All right, so why is that true? If I have 3 negative numbers, -1 times -1 is +1, Positive 1 times negative 1 is negative 1. So any odd number of negative numbers is going to give you that negative number, especially if it's a 1. So anytime I have an odd root of a negative number, it's negative on the outside. Now let's see what's behind the hidden door here. All right, a couple of examples. So the way I deal with this is I take the negative and put it on the outside, and then I simplify if possible. 8 is 2 times 2 times 2. I have to get 3 to pull 1 out. I do have 3, so my final answer is negative 2. I really should make that a different color so it shows up better. There. In this problem, I know I'm not going to be able to simplify the the fifth root of 7 alone, but I can pull the negative on the outside. And that is as much simplification as I can do with that problem. Rational exponents versus a radical form. Now remember, these are radicals, okay? So if you have a rational exponent, a fraction exponent, the bottom number of the fractional exponent, in other words, the denominator, is going to be the index for the radical, and the top number is going to be the exponent for the variable inside. All right, so if I wrote this out, we've got our radical symbol, we've got our x. Our index is 5 in this situation, and our exponent is 2. Now, let me just shorten that up a little bit. Now, I also want to show you one other thing. There's another way that this could be written. Let me just show you separate. You could write this in a parenthesis, and you could say a fifth index, or a 5 for an index, and then the 2 is outside. Either one of those would be acceptable. Personally, I like this one better, because if you had something out front, like 5x to the 2/5, and the 5 is not being raised to the power, then you can put the 5 out here. And in this, it seems like it would be in the parentheses, but you have to be very careful of working with that. But that's considered radical form. That's also radical form, but I like this one better. All right, so let's take a look down here. What happens when you start with the radical form and you want to go to the rational exponent? Well, as before, the index is the denominator, and the exponent is the numerator. Boy, I hope I spelled that right. All right, so x to the, let's see, I want to write this with the right colors, 3/4 power. X to the 3/4 power. So let's take this one and rewrite it as a fractional exponent. Well, 1 over x to the 1/3 power. Well, that's great, but that's not really just a variable to a power. One of the things that you hopefully remember from using negative exponents before, that if I want this on top, I would have to change the exponent's sign. So if I want to move that to the top, that's x to the negative 1/3 power. Now, if I start with a variable to a negative power and I want to rewrite it as a radical, I'm going to say 1 over x to the positive 3/4 power. Oops. And then I will go ahead and say 1 over the 4th root of x to the 3rd. And you would be expected to do that in these cases. So here's our final answer here when we're asked to rewrite this in exponential form, radical exponential form, and rewrite that in radical form, rational exponential form. Excuse me, I said the wrong thing. All right. Evaluating. Okay. There are a couple of ways you can do this, and I'll show you them both, or all three, however many there are. First of all, let's rewrite this in radical form. Let's do that over here. So that is the square root of 100 to the 5th power. Okay, that's not too bad. I can write this as, and I can put the 2, but I don't have to, it's understood. I can say that that is 100, 100, 100, 100, 100, 1, 2, 3, 4, 5. All right, I need 2 to pull 1 out. I have 1 pair, I have another pair, and this can break down to 10 times 10, giving me another type of pair. So that would be 100 times 100 times 10. Well, when I multiply powers of 10 up, I just have to add up the zeros and put the 1 at the beginning. So the final answer is a 1 followed by 1, 2, 3, 4, 5 zeros. 100,000. Well, what if I approached it slightly differently? I could have said, let me move all this up. In fact, I'm going to group it and shrink it a little bit. Now let's use a different set of colors. What if I thought of it differently? I am going to do this 3 different ways. What if I said the square root of 100 to the 5th? Now we showed that earlier. Can't I do the square root of 100? Isn't that 10? And 10 to the 5th power is just a 10, a 1, followed by 5 zeros. Again, 100,000. Well, believe it or not, there is another way I can approach this. 100. Let's think of a fractional exponent like a mixed number. 2 1/2 power. That's interesting. If it's the 2 1/2 power, aren't you able to, when you raise something to a power and you multiply it times that same thing to a power, you add exponents. Well, why can't we break it apart in the same way and say that that's 100 to the 2nd times 100 to the 1/2? Right? Because if I multiply, I add the exponents, I get back, right? All right. Well, if that's true, this is 100 times 100. This is the square root of 100, which we know is 10. Again, 100,000. it's neat to see those connections of properties of powers. All right, and we'll talk more about properties of powers tomorrow. All right, so now we want to solve an expression that is raised to the fourth power. All right, or any power for that matter. The first step in the process is you have to get the thing being raised to the power by itself on one side. So I'm going to start this process by multiplying both sides by 3. That gets me x plus 2 to the fourth power equals 81. All right, great. When solving an equation where you take an even index radical of both sides, you have to include the plus minus sign. Now, if it's not an even index, then you just include whatever sign is part of the number you're taking the radical of. So if it were a cube root of a negative 27, that's negative 3. There's your answer. If it's the fifth root of a positive 1, that's just 1. Because it's positive, it's going to come out 1. All right, so I'm going to take to get rid of the fourth power, I'm going to use the fourth root. If this were a cube root power, I'd use a cube root. So a 3 and a 3. The root and the exponent cancel each other out if they're the same. Have to do the same thing to both sides. Here, I'm going to get x plus 2. And on the other side, remember, we're including the plus minus sign because we took the fourth or even index root of both sides. All right, so I need to take the fourth root of 81. All right, 81. 9 times 9, 3, 3, 3, 3. I have 4 3s, I pull 1 out. Okay, let's continue this. I'm going to get rid of the 2 so I can solve for x. I like to put it before the plus minus sign. So that gets me x equals negative 2 plus minus 3. Negative 2 plus 3 is 1. Negative 2 minus 3 is negative 5. And you should always test it to make sure it actually works in your problem. 1 plus 2 is 3. 3 to the fourth power happens to be 81. Divided by 3 is 27. Negative 5 plus 2 is negative 3. If I have 4 negatives, that makes a positive, and 3 to the fourth power is 81. Divided by 3 is 27. It does work. But 1 and negative 5, or negative 5 I should say, are your correct answers. All right, so that's it for today. Have a great day.